Hi everybody, we're going to solve problem 1 on this worksheet. I hope you all are doing well. I'm trying to give you as much information to help get through this as I can. So post your questions in the discussion board and we'll get through it. Alright, so in this problem we are looking at a 500 kilogram pig. He's standing on the top of a muddy hill, so that makes me think about gravitational potential energy. So I'm going to put a little mark there to remember. The hill's 100 meters long. It has a vertical drop of 30 meters. So what that means, if you were to draw the sketch of it, the vertical drop is 30 meters. And the hypotenuse, or the length of the hill, is 100 meters, and the pig slides down the hill. So we want to find his speed at the bottom. That makes me think about kinetic energy. So if my system is the pig and the hill and the earth, I am going to give the pig all gravitational potential energy at the beginning because he's at the top of the hill. But then all that gravitational potential energy is going to be converted to kinetic energy when I get to the bottom of the hill with the pig. And because it is a muddy hill on a rainy day, it's really slippery. I'm going to ignore friction. Okay, so let's write our conservation equation. We know that EG, gravitational potential energy, equals kinetic energy, which is EK. Now, all you're going to do to turn that qualitative equation into a quantitative problem, because that's what it asks you to do up here, is we're going to substitute in our formulas that we learned from our notes earlier. Gravitational potential energy is equal to mgh, and kinetic energy from before is equal to 1/2 mv squared. So I can turn that equation into the quantitative version there. Now I can plug in some numbers. So I'm just going to do this here below the box. The mass of the pig is 500 kilograms. G on Earth is 9.8 meters per second squared. And the height of the hill, I'm going to use that vertical height, is 30 meters. That is going to all be converted to that kinetic energy, so I'm going to substitute in 1/2. M is the mass of the pig again, 500 kilograms. And I'm looking for that velocity. So I'm going to grab my calculator. 500 times 9.8 times 30 gives me the left side. And then I am going to divide that by 1/2 times 500, which is 250 v squared. So if you divide both sides by 250, v squared equals 588. Let me write it. I'll slide my calculator there. So then you need to take the square root of that 588, and that gives me a final velocity of the pig of 24 meters per second. So all of these problems are going to be set up that way. You want to go back to earlier when we just identified the types of energy in a system. Identify your system and then draw the bar graphs for the beginning and the ending positions. Write the conservation equation for it, and then use the formulas to solve for some unknown quantity that's being asked in each of the questions. Alright, so I hope that helps. You have the answers for the rest of these in Canvas. Good luck!